Centrifugal force. Consider an object spinning about an axis at constant angular velocity. This constant angular velocity we'll call omega. The centrifugal force per unit mass at a distance r from the axis of rotation is F on m is equal to omega squared r in the r hat direction, the unit vector in the direction of r. Remember that the centrifugal force is an apparent force only, due to the fact that we assume we're in an inertial frame of reference when in fact we're not. The real physical force is the centripetal force, or the centripetal acceleration, which is actually inwards. For this force we can define a potential phi c such that Fc, the centrifugal force on m, is equal to minus grad phi c. And it can be shown that this potential phi c is equal to minus a half of omega squared r squared. You might want to pause the video and show that that's the case. The geopotential we're going to define as the sum of the potentials due to gravity and the centrifugal force, represented by capital Phi. A geopotential surface arises from connecting all those points with the same value of geopotential Phi. The value of Phi increases in the outward direction. Differences in geopotential correspond to the amount of work required to move a unit mass from one surface to the other. That integral is shown there as the integral from a to b is minus f on m dot dl, which is the integral from a to b of minus grad phi, the geopotential dot dl. If we do that along a path d lambda, then you can break this up into partial integrals. It will be the integral from lambda a to lambda b of d phi dx by dx d lambda, how x varies along our path, plus d phi dy, dy d lambda, plus d phi dz, dz d lambda. And this may be written more compactly as the integral from lambda a to lambda b of d phi d lambda by d lambda, which is, in the end is just the difference between the geopotential at b and the geopotential at a. Phi b minus phi a. The geopotential for a spinning sphere is calculated by adding the geopotentials that we've seen before, that for gravity and that for the centrifugal force. Non-rigid objects bulge into an ellipsoid shape. For such an object we would have to modify the gravitational geopotential to be the potential for an ellipsoid and then add it to that for the centrifugal force. It turns out that the surface of the Earth is an ellipsoid because when it was forming it was molten and so was able to deform into an ellipsoid. Hence all the geopotential surfaces around the Earth are also ellipsoids.